Hello and welcome to our presentation for ASPiH 2021 on delivering high-fidelity ECMO simulation from a moving ambulance. I'm now going to pass you over to my colleague Lindsay, who's going to give you a bit more background about how this project came together.
So ECMO stands for extracorporeal membrane oxygenation, which is a type of life support machine which takes over the function of the lungs and the heart. There are two large cannulas or pipes that are put into a large vein and a large artery. The blood is drained from the body. It goes through an oxygenator which does the work of the lungs, so does the gas exchange part, and then it's pumped back into the body, taking over the work of the heart. And the blood's pumped around the body, so if the heart and lungs are not working very well, then this can take over that to allow them to rest and recover. Since 1989, we've been using the Extracorporeal Life Support Organisation came into existence. ECMO has been recognised for use in neonatal ECMO, so babies that are born and the lungs aren't working for a number of reasons. ECMO is used to support them until they recover. And NHS England commission respiratory ECMO in about 7 centres throughout the UK, and that's because there's only approximately 100 infants and children who need respiratory ECMO per year. And because the machine is so technical and so high risk, they concentrate the expertise into those 7 centres. And so there's a lot of movement of babies to those centres and can often travel quite a long distances to reach an ECMO centre. The Newcastle upon Tyne Hospital Trust is split across 2 sites, so it's the Freeman Hospital located here, and it's the RVI in the Great North Children's Hospital site, which is approximately 2 miles away. So since 2017, we've had to develop a mobile ECMO programme to be able to allow those children to come safely to the ECMO centre at the Freeman, and it allows the service to be provided throughout the trust. So the mobile ECMO training programme started on the back of this, that we had to go to across the city to cannulate patients onto ECMO and bring them back to the Freeman. And so over the past few years, the ECMO training programme for mobile ECMO provision has developed, and we've started to be able to do simulation based in an ambulance using the high-fidelity simulator that we have. And then as the mobile ECMO training provision programme has developed, we have decided to try and do the mobile ECMO training simulation on the road.
At the heart of the simulation is Chalice's parallel simulator. This system plugs into your ECMO circuit and allows you to control the flow of the circuit using a control tablet. The control tablet can also simulate patient vital signs that are displayed on a secondary patient monitor tablet. We used Laerdal's Sim Junior mannequin to simulate the patient, but this was not connected to any control input. Here you can see the diagram of how the system was assembled. I'll keep referring back to this as we work our way through. Our video streaming equipment was provided by Cameron Communications, or Camcoms for short. It uses 3 Axis PTZ cameras as inputs, which use real-time streaming protocol, RTSP. These are connected via a network switch using Ethernet cable. As well as the camera input, we take the output of the patient monitor tablet and feed that into the Camcoms box via a VGA input, converted to Ethernet and then sent to the main network switch. There is a control laptop running Camcom's C-Skills software for camera control. The output of this laptop is fed back into the box via HDMI into an RTSP streamer, which is connected to a router in the ambulance. Once the streamer is connected to the router, it is possible to retrieve the IP and configure the streamer to the desired output settings. This router allows us to connect a secondary laptop in a local area network with the streamer, so we can display the stream using VLC Media Player. The router has a 4G SIM card built in, giving us mobile internet access in the ambulance. This allowed the secondary laptop to connect to Microsoft Teams and share the streamed video content from VLC. We attempted a number of approaches to ensure that audio was intelligible while the vehicle was in motion. The Camcom system allows for an audio signal to be added to the video stream. We used 2 condenser microphones mounted in the ambulance, fed into a USB audio interface, which in turn were fed into the Camcom's box. We also experimented with lapel microphones on key participants and connecting the audio interface directly to the Teams laptop as the Teams audio input. We used mobile phones to maintain contact between the technician in the front of the ambulance and the control room to ensure that the patient vitals were correct as the scenario progressed. For each session, teaching groups would be made up of 3 to 4 candidates from the Freeman Hospital ECMO team and 3 to 4 candidates from NECTAR. Scenarios would be based around a paediatric patient currently on ECMO being transferred from one of the district hospitals to the specialist centre at the Freeman Hospital. One or two candidates from each service would take part in the scenario on the ambulance. They would be accompanied by a clinical educator from NECTAR who would play the role of a consultant, offer guidance, offer help, and help steer the scenario where necessary. A technician would be sat in the front of the ambulance with a relay back to the centre to ensure that patient observations were correct, the scenario progressed as intended. The scenario, as explained, was streamed via Teams in real time back to the centre so the remaining candidates could observe everything that was happening in the scenario as it happened. Using Teams was really useful as it meant that we could stream the scenario back to the centre where people were watching, to the control room so the faculty were able to guide the scenario as it was running, and also to other interested parties elsewhere in the trust.
And so it's collaborating two teams, one very used to transfer but not used to ECMO, and a team that's very used to ECMO but not used to transport. So by having the simulation within an ambulance that's moving, you are emphasising how noisy it is, how bumpy it is, sort of the temperature, sort of how difficult it is to communicate, the sort of space that you have in an ambulance, which is different to sort of an ECMO bed space where it's a lot more movement. So it gives the ECMO team who don't have as much transport experience a lot more understanding of what sort of communicative, environmental factors that can impact a mobile ECMO transfer. And then conversely for the NECTAR practitioners, the transport practitioners, they get used to how ECMO sits in the ambulance, how the movement of the ambulance might impact upon the ECMO circuit and how the blood and the gas flow works. And so by moving the simulation on the road, it sort of highlights those environmental factors that you can't get in a simulation centre. The feedback has been really positive so far. Everyone's thoroughly enjoyed the sessions that we've ran in conjunction with NECTAR. Initially, when we first started the programme, the simulations were based in an ambulance stationed outside the simulation centre, but we felt that even though this was really good and the feedback was positive, that we weren't really, we could potentially enhance the learning outcomes more, and I gave Tom the challenge of doing this while the ambulance is moving. So we spent a lot of time and effort thinking about how we could do this and organising it. So then for the next sessions, we were able to stream and do the simulation on the move. And the candidates that participated in that thoroughly enjoyed it. They felt it really enhanced the learning outcomes that we wanted to achieve. So that was human factors, communication, environmental factors.
From a technical point of view, this was quite a complex challenge that Lindsay set me, but we used what we had available and we were using it in a manner that it was not quite intended for, so that always presents some issues with reliability. So we would rigorously test all the equipment before any simulations took place. However, being able to stream simulation to a wider audience is always helpful, and we've done other projects in the Trust where this has been the case, especially when interested parties are not physically able to attend. So streaming meant that they could dial in and view the simulations remotely when they had a chance.
I would definitely recommend doing mobile ECMO simulation on the move because you can really enhance those factors that will influence a transport that you can't get within a traditional simulation environment. Particularly if you are like what we are, collaborating two teams together, having simulation on the move will really highlight those sort of environmental, human factors differences that take place on a transport. So I feel other ECMO centres can definitely use this to their benefit, but also that the method of doing this type of simulation is transferable, so out with ECMO centres to other transport services, and it can be used for new practitioners that are learning about sort of transport, and you can simulate how through the controllers you can simulate acceleration, how that might affect the patient and things like that, to embed those key skills into new practitioners. And as well as this, also for senior medics, senior practitioners in the transport service, to keep those competencies and skills up in high risk, high pressure environments where they transport the patient and the critically ill.